Okay, hello. I see a few people are out there, so it's nice to have you for the live stream if you could make it. And if you're watching the video later, I hope that your week has gone well. Um, we're in week 3, which uh, I don't know if I'm the only one, but um, we can. This is a point in the semester where it feels like we're a ways out um, from when we get to the end of the semester. So kind of the long grind of the semester starts to show its presence, at least sometimes in one's mind. So hopefully you will find enough of the work that we do in our class interesting, challenging, sometimes satisfying, um, that there are parts of it that you come to look forward to. It can be a very creative thing, and I know it doesn't always feel like that because I'm kind of instructing you about what it is that I want you to do. But um, we will have, we are building up a skill set so that we can get to a project in a lab or two later in the semester where you have a lot more freedom to kind of explore your own ideas. So for now, just sort of think of it as this time when we're um, developing our skills at a craft, and then we will look for our opportunities to use our craft, and be creative with it. And I would point out that a lot of you did that on the week 2 lab, so that was really cool to see. That a lot of people did small experiments in the week 2 lab. They added extra outputs. One or two people actually sort of took some of the information and changed the order they were presenting it, which I thought was a really smart way to experiment with doing formatted outputs. Almost everybody did formatted outputs, and that's usually the people who didn't do formatted outputs is usually an indicator to me that they simply didn't watch the lecture, or they didn't look at the samples that I provided. So hopefully those people are out there, and hopefully they're finding some value in the live stream. But for the vast majority of you did really great on the lab, so good on you. Pardon me. You're going to find that this week's lab, in one way, it's kind of boring because it looks like almost the exactly same lab, but we're adding in a new component, and I want you to have time to develop a feel for it, which will be having your user, which will often be yourself, but you will be creating interactive software in that you will be asking a person questions. They'll be typing in answers at the keyboard, and then you take the information supplied to you at the keyboard and using it in your program, which opens up a whole bunch of new possibilities when you can do interactive software. So it's a lot of fun to do. In terms of recapping, so the things to be paying attention to as we move forward, and you'll get plenty of practice, but declaring variables. So we have the var keyword. We name our variables. A few people just had sort of A, B, C, D variable names, and as we talked about last week, it's considered bad style for one thing because it makes your code hard to read for yourself and other people. And you're missing out on an opportunity to have your code kind of document itself, in the sense that a person can open up a file of your code and begin to read it as normal words and make sense of it. So don't use variable names that are A, B, C, D. Use things like favorite color, first name, date of birth, those kinds of things. Use good variable names. We talked about data types. So for us, int, float 64, and string are the main ones that we will use all semester. At a point, we'll also introduce the Boolean data type, but we don't need that yet, so we're not going to get distracted by it a lot just yet. And then the other thing to be on the lookout for is the difference between being asked to declare a variable and reuse a variable. So when we say declare a variable, we mean make a brand new variable in your program with the var keyword, a name for the variable, a data type, the equal sign, which we call the assignment operator because it's how we assign values to variables, and then a value like var first name string equals Boyd in quotes. So that's declaring a variable versus reusing a variable, which would be somewhere later in the program after a variable has been declared once. You go back and you reuse first name, and you would say first name equals John, which is my first name, as it turns out. That's reusing a variable as opposed to declaring a brand new variable. So anyway, be on the lookout for when I use those words in your labs, the difference between declaring a variable, which is the whole thing, I'm making a brand new variable with all the information about it, and reusing a variable where I'm taking a variable that was already declared and I am assigning a different value to it and then using it with its new different value from thenceforward. Okay. Pardon me. I'm going to switch over to Replit. No, I don't need to do... Yeah, let me do that. Let me switch over to Replit. Create a REPL. This will be a Go REPL. I will call it CSCI 20 underscore week 3. So I can put some notes on the screen. Some of these are easier to look at when they're typed. Okay, so formatting verbs, which is the term that you're reading, one of your readings at least, used to describe these things. Why that jumped over, I don't know. These verbs, which is % followed by a character, that allow you to place a variable into an output, which was meant to be what your week 2 lab was about, and 95% of you or so watched the lecture, saw the samples that I provided from lecture, and did exactly that. If you're still using format.println, then you've gotten yourself a little bit behind and you need to catch up, because we don't do println. We want full control over our outputs, and format.printf gives us that full control. We're going to use it exclusively for our outputs. And one thing to remember about formatting float type values is that we're probably almost always, if not always, going to specify as part of the formatting verb how many places past the decimal point we want to have printed. And the way you do that is you put a decimal point in between the % and the F, and then this number represents, so that's one place, that'd be like 99.5, 99.12, 99.1234. That's how you can specify how many places after the decimal that you get in your output. For money, it would typically be 0.2, right? 1.99, meaning $1.99. And maybe for temperatures, you might just use like one place past the decimal. It depends on your needs. But that's how you're almost always going to see this used as a formatting verb. The other thing is this thing. In terms of output, it is not a formatting verb. I won't even say the extra word. So this \n, it causes a line break to happen. I know most of you haven't used an old style typewriter, but hopefully many of you have seen an old style typewriter where someone's clacking away at the keys and they get to the end and they hit the enter key and the carriage of the typewriter slides back to the left and advances a line so that when you start typing more characters, it's at the next line down. In fact, it happens when you type digitally, right? So I'm going to press enter. That's a new line. Type some stuff, press enter, that's a new line. So all of these lines that come to an end and then have lines after them actually have one of these hiding out in there that you just can't see, because we don't tend to show those on the screen because they don't really offer anything useful. But when we're programming and we want to go to the next line down, we insert these things to cause that to happen. You don't need spaces around it, so you can get some output statements that look weird because they have so much stuff going on. So let me just give you an example of that. I'm going to have to I'm going to have to comment these, or I will get errors when I try to do something in the program itself. All right, so we don't use print line because that gives us no control over our output. So let me just do a whole bunch of different stuff. So I'll do var product name string equals gumdrops var product price float 64 equals 0.97, let's say, var units purchased int equals, I don't know, how many gumdrops do you buy at a time? Let's say 100. Okay, so let's do a print statement. First, we're just going to do a welcome to gumdrops or us exclamation point. So let me just show you what happens if I don't use new lines anywhere in my output. Now, some of you didn't in your lab Tues, and I made a comment about it, but I probably didn't dock any points for it. But you want to pay attention to this kind of stuff. Run your program, look at it on the screen, ask yourself, how can I make it look better? Because humans being human, I'm one, you're one. We being humans, we tend to think that what we're seeing is a representation of the underlying quality of the thing that's being presented to us. So if your program looks good on the screen, that just immediately creates the impression for me that it looks good in the code. And it also creates the impression that you took time and care to make it look good, which reflects well upon you. And for me personally, when I run my own programs and they look nice on the screen, that feels like a reward. I don't want to make slop, I want to make pretty things. So let me make some slop and then I'll make it pretty. So here's a way that I go about doing these formatted prints. I sort of imagine myself, so I'm going to say like units of product for price per unit, something like that. And then format.printf, come back soon. Okay, so I'm going to run this, and you'll notice that there's no variables in here. So what does this look like if I just run it? Some of you know because you are experimenting, and that's a good thing. So we'll look at the screen below, and we will realize, oh, that it's not going to let me do this because these... So if you get these errors where it says product name declared not used, declared not used, declared not used, you can temporarily disable those or comment them out. Which is what you should do. The way I did that all at once and quickly, by the way, is I highlighted all three lines, and then I held the control key down and I pressed the / key once, and that commented all three lines out. / key, this is a / it leans that way. Another way to think of the / is it's the easier one to type. At least in my opinion, it's on the it's below your pinky as opposed to way up above it and off to the side. So the / is the one that we use more than the backslash, and that's because, in part, maybe because it's easier to type. Anyway, I'm getting these errors, so I'm going to disable the code that's causing the errors, and I'm going to try to run my program again. Okay, so this is what I would call slop. It looks like crud. It's just a whole bunch of mess printed out on one line, and no good programmer is going to leave that sitting like that. Just think about any area of your life where you have developed some skill and some expertise, and ask yourself if you would leave it as well enough to do a sloppy job. And I bet the answer is no at whatever or wherever you have already developed some knowledge and skills. So we want the same thing in our programming. Don't settle for slop. So let's see, what should we do? Well, let's start by separating the lines from each other. And the way to do that is to go, so I want this line, for example, the one from line 12, gumdrops are us, to be separate from this line. So I'm going to insert a line break at the end. It takes practice to read this stuff until you get used to it. But once you get used to it, then your eye will find these new line characters, and you realize, oh, it's going to print welcome to gumdrops RS exclamation point, and then break down to the next line. You don't need spaces around it. In fact, if you put spaces around it, weird things happen. In fact, I'll just do that and I'll show you where that shows up. So let's line break there. Okay, that's better. Why is the second line spaced? Well, because I put a space there. It's hard to see, but I put one. I put one right here at the end of line 12. So what I told Go to do is print welcome to gumdrops RS exclamation point, followed by a space, which will be here on the screen, even though it's invisible, followed by a line break, which it did, followed by a space, which it did. So I don't want that space, and I don't need it, and I don't actually need this one either. So the space does nothing other than potentially mess up my output. So let me run it again. That looks okay. I think it would look even better if there were two lines between welcome and thank you. So I'm going to put another one. Just two in a row. And let's try that. I like that better. There's a little bit of space there. In fact, I think it would be nice if there were one above the welcome, so I could go in right before the welcome and actually cause a line break to happen before the welcome message comes up, and then I'll get a line break. Even better. Thank you for buying units of product for price per unit. I should probably put a period at the end of that, but I should also get a line break in there after the second input and before the third input. And in fact, maybe I should put two, because I already have a sense I'm going to prefer the way that looks in the end. Okay, now I'm starting to feel a lot happier about things. This last line, even though it doesn't really matter, it has this little yellow caret next to it. So I'm going to put a line break there too. Okay, that's what I want. I could even put two off this one, and maybe that would be exactly what I'm looking for. Okay, I think that looks all right. So the point here is that you can try these things out, move them around, try more than one. You don't want tons and tons of blank lines here, but enough to make your things look pretty. Okay, now let's deal with this thing in the middle that is meant to have actual data and not units. So this is a left to right kind of thing. So I'm going to start using verbs to take the place of where I want units to go, and then I will put the units variable at the end in a list. So the units, which now needs to come back in, the way you re-enable a line is you put the cursor on it, or you highlight the line, either way, and you hold the control key down and press the / key, and it is re-enabled for you. Okay. So I have re-enabled units purchased because that's what I want to plug in here. So the formatting verbs. I remember that %d is the way that I format an integer for output. So I want to put an integer in here, and then after what's to be printed, I put a list of what's to be filled into the gaps left to right. So this is the leftmost item, and what I want it to be is units purchased. And I can just do one of these at a time until I get what I want. So I'm going to run that. Thank you for buying 100 of. I don't know if I need the of. I'm going to take that out of there. All right, so there's the first one. The second one, going from left to right, is the product itself, which is this variable. So that's a string. So the verb is a string. And then left to right, I add to this list, separated by a comma, the thing I want to go into the second slot. So units purchased goes in the first slot, and they match. It's an int. This is a verb for an int. The second slot is a string. This is a string. All right, 100 gumdrops 4, and then the last one is price. So price is a float, and the most basic way to output a float is just %f, but hopefully we have the sense from last week's lab that we should probably be specific about how many places past the decimal we want. I want 2 places past the decimal because it is money. And then that's the third item, so I add a third item to the list, followed, separated by a comma. Re-enable product price, and then plug it in. And everything is as I would like it to be. Yeah, so there you go. There's a quick review of formatted printing. For those of you who aren't doing formatted printing yet, there will never be an occasion in this class where it's not expected that you will do formatted printing. Occasionally you'll figure out where you can get away with a print line and it not affect anything, but in my opinion, life is way easier for all of you if you just always do formatted printing. Always. Even if you don't have anything to actually any variables to actually plug in, that's fine. Notice it didn't affect anything. And then I control how many new lines and everything I want manually. Okay, so there is formatting. Notice that when we output floats, we typically specify how many places past the decimal we want. So now let's change it up and make it more interesting. For the user to work with. So we're going to do keyboard inputs. And you're going to see a familiar pattern here with these formatting verbs. So let's do a sequence. In fact, let me set you up so that you understand the sequence. I'm doing this with the forward slashes so that it doesn't become a part of the program and cause errors to print on the screen. So I'm just putting some notes down here at the bottom that won't have any effect on the program itself. So we are going to start handling keyboard input this week. So how do we do this process? So the first thing that you do is you prompt for input. And when we say prompt for input in programming, what we mean is you print a question to the screen. I'm going to do one up here. And I'm going to do it actually in the store itself. So after the welcome message, I'm actually going to do this work. Yeah, that's where I want to do it. So what does a prompt for input look like? It looks like this. I'll come back and we'll explore printing this prompt, and I can just show you my style. Here's a prompt. It's typically a question or some direction to the user that you want information now. What product are you buying? I tell the user. That's the first step. The second step, which is optional, but if needed, declare a variable to receive the input. So what I'm going to do is I'm going to take this variable product name and I'm going to move it to my little sequence of events for keyboard input. I'm also going to take off gumdrops and just leave it in its 0 valued state. Since we're about to have the user type something at the keyboard and we're going to store what they type in this variable, I don't really need to set a value to it. I'm just going to declare the variable. It's going to be in its 0 state, which for string is empty string, which is nothing. And then I'll be ready for the user to type in what they want. So 3. So this one's going to look very different from the code that we've written up to this stage. So we're going to use scanf, which is scanning for keyboard input. And I know that seems weird to call it scanning. There is a technical reason for that, but just get used to it. When we want someone to type information at the keyboard and we want to capture it in our program, we're going to scan for it. And we're using scanf with a verb. So the rest of this is going to be the stuff that looks very different and very new, but there will be some things familiar in it that hopefully you will recognize. So we're going to scan. So this line right here is going to capture the keyboard input for us. So the way we start a scan is we say what kind of thing we want to capture. I want a string. Why do I want a string? Because it's the product name that I want them to type in. So what I'm scanning for, the verb, is going to match where I want the information to go. All right, then some weirdness. Which is unfortunate, but this will sort of eliminate problems for people who may try this software out outside of Replit. So in Replit, you only need the \n. And what this represents is what we're telling the scanner is take some characters from the keyboard and consider it done when they press enter, which is this. So that is sort of capture everything up to that moment when they press enter. That's what that new line is telling the scanner. I want everything up to when they press enter. And this will work just fine in Replit, but because occasionally some people will go into Windows, we have to add this part. So in Windows, you need this 2-character combination for this to work, unfortunately. If you're on a Mac, if you're on a Linux system, if you're inside of Replit, you don't actually need the \r part. But if ever this software finds itself on a Windows system, you're going to need the \r because Windows, on a Windows system, pressing the enter key is actually a 2-character code. This represents carriage return and new line. So on Windows, the process of the carriage sliding back to the left and the roller advancing to the next line is actually 2 steps. Everywhere else in the world is just 1. So I know that's confusing. You'll get used to it. You're going to practice it a lot this week in lab. You'll just get used to what the scans are supposed to look like. The verb that I want, and then this 2-character combo to make sure that I get everything up to the end of the line. When the user at the keyboard says gumdrops, enter, that's what that is meant to deal with. Okay, that's the first half. The second half is where do I want it to go? And we're going to have to introduce a new character here. So the second part is where I want it to go, and it has to start with this ampersand. It has to. There's a technical reason for this, and we will talk about this and get you to an understanding of it at some point in the semester. But again, this is one of those things. Get used to what the scans look like because they're a little bit unique. This whole process of getting keyboard input, but they're not hard. You just get used to it. So we need the ampersand, and then we need where we want the keyboard information to go, which is in our variable product name. So I know that whole thing looks weird, but if you repeat it enough times, you'll just come to recognize when it looks right. And if you do it wrong, I will actually take the ampersand out so we can see what happens when should I do that. But let's run it now and just see if the product name is something that I want. All right, so here's the prompt. Notice that the cursor is sitting at the end of the line on the prompt. What product are you buying? Space, stop. And that's because my prompt did that. My prompt said space, stop. And now the program is sitting there waiting for keyboard input to scan. And it's going to wait until the user presses the enter key. So what do I want to buy? I'm going to do, I don't know, pretzels? So I've done the character part. This is the %s verb stuff. And it's still sitting there waiting because I still haven't pressed the enter key. As soon as I press the enter key, it's going to know I'm done with my inputs, and it's going to take whatever I typed in and store it as product name. And then when it turns around to print product name, notice it's now printing pretzels instead of gumdrops. Okay, so how would I know if I've screwed this up? Well, let's take the ampersand out and run the program again and see what happens. Well, crud, there's no errors, so that's not helping me. But let's go ahead and try to buy some pretzels. There's nothing in the output. So without the ampersand, the information actually just gets lost. More or less, it just sort of goes into a black hole. So you need the ampersand, or the keyboard information is going to be lost down a black hole. So that's how you would notice when your program's running, if you had made that mistake, is the information is gone. Where'd the information go? Oh shoot, I forgot the ampersand. So I'll put it back. I will rerun the program. I'm going to buy something different now. I'm going to buy shoes. And I bought a lot of them, but they were affordable. Okay, let's repeat the process for the other pieces of information and let the user kind of type in what they want. So we're going to use the same process for the other two. We're going to prompt for input. We are going to, as needed, declare variables and leave them in their 0 state. And then we're going to use scanf with the proper verb to capture the keyboard input. So let's do, that's the product I'm buying. Let's do the units. So printf. How many? Watch what I'm going to do here, though. I'm going to actually turn around and immediately do you want, which makes me feel very clever as a programmer, because I'm actually going to make the next prompt include the product that they just typed in. How many pretzels do you want? Which is going to wow them, right? Wow, you just got that information and you're immediately showing it back to me, which is pretty cool. So here's my next prompt. Let me put a new line character here. So notice I took the space out because the space don't do anything anyway in that case. I'm going to put a new line on this prompt, and then just we'll compare and see which one we do or don't like better. I already know which one I like better. So there's my prompt, and I actually took advantage of the fact that now I know what they're buying to show it back to them. How many shoes do you want? I'm going to move my variable declaration here. I'm going to not give it an initial value, but leave it in its 0 value state because they're about to type it in, and then I'm going to scan for it. Scan F. So units purchased is an integer. I use the same formatting verb as I would when printing an integer, which is nice because it's the same verb in both directions. And then I realize that I have to remember this little sequence for all of my scans, so that I get not only the integer matching part, the %d, but also that press enter key. And just in case they happen to be running it on Windows, which is a stupid operating system, we'll get that extra bit of the procedure of doing a line break. And then we're going to do units purchased. If you're in chat, by the way, and you notice anything wrong, you can say it as we're going. I did something wrong on purpose. And it's okay, but if there's anyone who wants to venture an idea, somewhere in the units purchased procedure, I did something wrong. And it will show when I run the program. But maybe someone out there has seen it and can catch it before we run the program. There you go. So the Dan bar, the error on line 16, I'll see if I get it. Carrick Boy's got the nice Dark Bandit 2. So on the scan, I missed the ampersand. And had I missed it, that information would have been lost. So you guys caught it before I ran it. And then the Dan bar, we'll see if I get an error on product name. I don't expect to, but we'll see if I do, and then we can diagnose it. Okay, I didn't, so there's somewhere there's an error in your code, the Dan bar. I'm going to buy a bicycle. I'm going to buy... Okay, so I want you to see the prompt here. This first prompt was all on one line. So the first prompt is all on one line, and I typed my answer on the same line. And that's because the prompt doesn't have a new line at the end. It does have a space, which is why there's a little space here. And I happen to prefer this style where the question and the answer are on one line. Now on the second prompt, the reason why it's waiting for me to type my answer on the next line down is because I put this new line character on the second prompt. I personally don't like that style, but some people do, so that's up to you. Just note that if you put a new line on the prompt, then they type their answer on the next line down. If you don't put a new line, you should put a space, and then their answer will be on the same line. So how many bicycle do I want? I want one bicycle. So thank you for buying one bicycle for 97 cents per unit, which seems like not a good amount. Hopefully the Dan bar, you can you'll see what the issue is. So if when you're programming and you get errors, check for things like the spellings. So sometimes I'll accidentally spell a variable name wrong, or I will use the wrong sort of upper and lower casing on the variable name. Okay, yeah, so it was a case sensitive issue, which is a common error that we all make. And it's like becomes pretty early. What you tend to check is, do these things all match? Or did I spell it different? Either literally spell it different or change the casing. Okay, so there is units purchased. I'm going to take the new line out of that prompt and put a space because I like the way that looks. And now let's do the last one, which is print F. Choose your price. Name your price. This is the best. And in this case, I'm going to make the prompt have a $sign next to it, just to sort of tell my user, hey, I'm expecting an amount of money here. So this is the best store in the world because you get to name your price on the things that you buy. Um, okay, so there's my prompt. So I did not use a new line. And in this case, I didn't put a space after the $sign because I want the price that they type to be butted up against the $sign. Second part is to declare a variable if needed. So I'm going to move the variable declaration. And this is just considered good style. If you're declaring a variable for the purpose of doing an input, declare it where you're doing the input. Declare it next to the scan. Name your price. I'm going to leave it in its 0 state because it's about to get its value from the keyboard, and then I'm going to scan for it. This one's a float. And then you'll see in my notes that I said, where did I say it? Printing floats versus scanning floats. So the reason why I put that in my notes is that when you scan for floats, I recommend you just use %F and you don't do the point thing in the middle of it for scanning. For printing, you're almost always going to use the point some number of decimal places for printing. For scanning, just use %F because they might just say 1.9 and you don't want to break it on that. It'll just be $1.90. So anyway, for scanning, just %F without the dot thing in the middle. For printing, put the dot thing in the middle. Don't forget that I need to read all the way up to the new line and then product price. But for printing, notice I am going to format it so that it looks proper for a value. So let's run that. What am I buying? I'm going to buy a spaceship this time. How many spaceship do I want? I just want the one. So I'm going to say, I don't know, 50 cents. And notice how I've typed it, which should be okay. But then you'll notice when it's printed, it will look prettier again because of my formatting verb with the dot stuff inside of it. Name your price. Thank you for buying. So notice now it says 0.50 like I'd expect it. So for scanning purposes, I was forgiving that the user might do this. So I just put %F and they put 0.5 and that's fine. But for printing purposes, I put %.2F so that when I printed it out, it looks like normal money stuff, which is what we would all expect. I think I should probably put a space before the thank you. So I'm going to add a space before the thank you. There's 2 ways to do this. I can use a new line at the front of the thank you, and that would be okay. If you feel more comfortable with it, you can do this, which might be easier for you to find that, oh, I just wanted a blank line there. Some people do that, and it's fine, style-wise. It's obviously a blank line because all it does is print nothing but knocks the line down 1. So that is an okay way to insert a blank line somewhere if you like the way that looks. We'll run it. I'm going to buy 100 gumdrops. Go back to the gumdrops. Oops. So you'll notice that's a good thing that you saw that. So what went wrong? Well, it asked me what product I was buying, and I put 100, and it assumed that the product's name was 100, whatever that would mean. But then when I said how many 100, I typed gumdrops, and the program just kind of barfed on me. So that's okay for now. We'll be more careful. We will later in the semester look at how do I deal with that situation when my user is being an idiot like Boyd just was and typed gumdrops when they wanted a number. For now, we'll just note that that happens and we'll be more careful when we run it again. What product am I buying? Gumdrops. How many gumdrops do I want? 100. So I'll just pay closer attention. Name my price. I don't know. I want to pay like I'll pay 25 cents. That's a lot for a gumdrop. How about 2 cents a gumdrop? There's my extra blank line. Thank you for buying gumdrops for 2 cents a unit. And then come back. I could even, if I want to, by the way, instead of saying per unit, No, let's leave it at that. That would introduce other complications that would make me unhappy. So we'll wait on that. So there you go. There is handling keyboard input with all of the different data types that we care about right now, which is strings, float 64s, and integers, which is a %d. Unfortunately, it's not a %i. And then remember the ampersand, super, super, super important. And also, when you're scanning for floats, I recommend that you just do %f and not worry about the point whatever in the middle. When you are printing for floats, you do worry about the point whatever in the middle so that you make sure that your outputs look good. And then you allow your user to be sloppy on their inputs if that is what they're going to do. Your user being whoever it is sitting at the keyboard typing stuff. Okay, so there's all the basics of that. All right, we're in pretty good shape here. Let me go and now walk through the module and then stop on a thing that I want to show you before I go past it. So let's go look at the week 3 module. I kind of got ahead of myself, but it's fine. So week 3. So prompting for inputs. We talked about doing that with printf. Declaring variables of different types to store user inputs. We just actually did that. And then scanning with verbs to read and store inputs. We did that. So we've looked at that. So here on the readings, I want to look at some technical documentation, which will be our first time to kind of look at technical documentation. The reason why we're doing this so early in the semester is that it takes practice to read technical documentation. So let's start and just see what we find. So I'm going to pop open both of these items and then I'm going to go look at them. So here is the technical documentation for this thing called FUMPT, which is short for format, and it's sort of the Go style. But what FUMPT is actually referring to is what's called a package in the Go language. And packages are collections of utilities, is what we'll call it for now. It's collections of things that we can use to make our programming life slightly easier, even though at this stage it may not feel like it. So right now, what we are using from the FUMPT package is printf and scanf. So those are two utilities, which is what we'll call it for now, in the FUMPT package. One for helping us print stuff to the screen in a formatted way, the other for reading input from the keyboard, specific to different data types. So if you scroll down a little bit, you can just start practicing a little bit, reading this documentation. So this is the exact same documentation that professional programmers would use who program in the Go language. So there'll be some terminology that's not familiar, and you just kind of, for now, it's okay to glance over it. There is a hint in here because one of your homework questions asks you something. So package FUMPT, I'm reading this sentence, package FUMPT implements formatted I/O. This means formatted input and formatted output. We have just done an example of both. We have done formatted input with scanf, and we have done formatted output with printf. With functions, which is what I was calling utilities, the more formal term for those is functions. So scanf is a function, and printf is a function. But it may help you to think of them as utilities that you're using in your programs. Analogous to similar functionality in the C programming language. So there is a question that you ask about the verbs, and you will find that the C language is probably one of the answers. The format verbs are derived from the C programming language, but are simpler. That's good to know. And then if you scroll down, you will find listings of the verbs. We are most interested in some of these down here. And you'll notice there's just a whole bunch of them for integer as an example. So we are using base 10, which is decimal format integers, which is what we're all accustomed to in sort of our normal life. So that's where the %d comes from, is that we want base 10 integers. Here is the %f. Decimal point floats, but no exponent. And then we are also using the %s, which is going to read weird for now, the uninterpreted bytes of the string, which is really saying just the characters as presented. Okay, so there's a lot of formatting verbs, and we have whittled it down to just 3 for now that we will gain some mastery over: %d, %f, and %s. But there are many others. Okay, so the reason why that reading is there is because there is a piece of information in it at the top that will be useful to you on the homework, but it's also there so that you can be introduced to what the actual technical documentation for Go looks like. And this is what it looks like. There's a lot of documentation in here, a lot of words. Don't get overwhelmed by it. Just kind of poke around a little bit. Some things might make sense, others might not. It's just to get our eyes on it for our first first pass at it. The other one is going to take you straight to scanf. So what this is the documentation specifically for this new function that we are using. Now, I've already given you examples of how to use it, so you don't really have to worry about interpreting this documentation. Again, it's just to get us used to reading it so that later in the semester, when we want to get more power out of this documentation, we'll already be familiar with what it looks like, and we can make more sense of it with the practice. So func scanf. The main thing is to just try to read the text description of it and see if we can make sense of any of it. So scans text read from the standard input. So in programming, when you see the term standard input, that means the keyboard in almost every case. So that's how on the technical side of things, we refer to the keyboard is the standard input. The mouse would be a non-standard input. The keyboard would be considered the standard input. Storing successive space-separated values into successive arguments as determined by the format. That sounds a little bit intimidating, but this format part is a reminder that that's why the verb is there, is that we have to specify the format that we want. And if you look up here, you will actually see that here is a reference to the format yet again. So that's why we put that formatting verb in there, is because the documentation tells us that you have to. It returns the number of items successfully scanned. We're not using that information, so we don't need that. This stuff about errors we will use later in the semester, which will be a way to figure out if the user typed the word gumdrops when they were supposed to type a number. But we're not going to worry about that information for now. So again, these are here so that you have your first exposure to the actual technical documentation. Any questions written from this technical documentation are designed to be super, super simple. So don't go digging in real hard unless you want to. Just kind of have a read through it, and when you see things that you don't necessarily understand, that's okay. More of it will be more understandable the more times we revisit this technical documentation. Okay. So there's the reading and the lecture part. Homework is always based on those readings, but it's all meant to be relatively simple, so don't let it overwhelm you. The lab. So let's go look at it. The code part. In fact, I'm going to put it in Replit. I've copied this. I'm going to put it in Replit in just a moment, and we'll. But like last week, we had numbered elements, and we need to do code to satisfy those numbered elements. So I'm holding on to the copy of that, and I'll paste it into Replit in a moment. So the week 3 filter is more Go resources. So this is revisiting a same topic, but hopefully as you are gaining more experience and confidence, the nature of the resources that you find useful will get slightly more sophisticated, and maybe you've also in the meantime found some resources that you didn't talk about in the last discussion that you think have been helpful to you. So that's just building on an earlier discussion and trying to get more options for more supplemental learning materials for ourselves. And then the last is the reminders, which includes Project 1, which is due on September 18th, which is not very far from now. So we are going to look at that today, yes, before I stop talking. So I'm going to open that, and then I'm going to go over and look at the lab, and then we'll look at the project. Okay, so the lab. Let me create a new REPL. It'll be a Go REPL. It will be CSCI 20, lab 3. And I will paste this stuff in. Make it look a little bit better. Okay, so there's a lot more instructions, but we've just been through how to do all those things. Better a name on here. By the way, I think literally 100% of you who submitted labs had the documentation completed, which is relatively unprecedented. Even with the second semester programming students, some of them will sometimes overlook the documentation. So that's a very good thing that you're just knocking that out. You want to be in that habit. This is your code. Once you have entered it in here, it's your code, and this is sort of your copyright. And it's also the way that you document your submission, as you would with a paper in an English class, let's say. Okay, so there's a note. Just like last week, all the prints need to be printf style. We want to master that so that we can also then have full control over our outputs. And then scanfs for all the inputs, and that's all the examples that I will have shown. Okay, so here we go. This thing is actually walking me through the whole process of prompts, variables, and inputs. So 1A, prompt the user to enter the current day of the week. There's two ways you can do this, in my opinion at least. You can sort of command the user to do it. So enter the current day of the week. I like the no new lines at the end. You might decide that you like a new line where they type their answer on the next line down. I usually just go with the space and then they type their answer on the same line. So you can go with the do this thing kind of prompt, or you can go with the kindly supply me this information kind of prompt, where you ask them a question. The style of those is entirely up to you. What is the current day of the week? There's the prompt. I need you to do something, user sitting at the keyboard. 1B, declare a string variable. So declare a string variable with a good variable name, not A, B, C, D. That's just terrible programming style. And I will dock you points for it because I do not want you leaving a class that I taught being a bad programmer. And if you use A, B, C, D as your variable names, you are a bad programmer. So I don't want you to be one. I don't want you to train you to be one. So that's why I will not do it. You could do this, though, in a variety of ways. You could say current day of week. That's fine. It's not too long. You could just say day of week. Or you could probably just say day, and that's adequate. So that is also kind of a style thing that you'll have to decide for yourself. But don't use single letters for variable names. It's just terrible style. It makes it hard to read your code. Nobody else is ever going to want to read your code. You're going to find that it's more difficult for you to read and fix your code. So just develop this as a good habit to have and carry forward. I'm leaving it in its 0 value state because I'm about to capture it from the keyboard. So I'm going to scan. What am I scanning? Well, day, which is a string, so the verb is a string. I remembered to do this Windows weirdness, and then waiting for the person to press enter. And then don't forget the ampersand when you're scanning. Where does it go? It goes in the day variable. That completes 1A, 1B, and 1C. So I'm going to continue that process. I'm going to get the current month, declare a string variable, scan a value, prompt for the current date, declare an int variable, scan for an int variable, current year, which will be an int variable, scan for an int variable, and then print the message. So this is exactly the same lab as last week in terms of the information. The difference is the person sitting at the keyboard is typing the information interactively into the program before you present it. So you can and you should, in fact, refer to your week 2 lab for help with things like displaying this information. Because most of you did printf and you did it correctly, and that's how you will do it again. Okay. Yeah, that's kind of it. This one's a little bit simpler in that you don't ever have to reuse or reassign a variable. For the second part, you prompt for a city, prompt for a temperature, and then print out that information. Remember, and this one's a little bit different because I said 2 digits after the decimal. When you are printing a float, you put the dot stuff in the verb. When you're scanning for a float, don't. All right, there's the lab. Yep, we're doing wonderful on time today. So let's talk about the project. So I don't intend to upload this as a sample. I will upload the week 3 stuff as a sample because it has a sample of all of the things that you need. So let me go back and make sure that I put that where I can find it. I want REPLs, please. My REPLs. Okay, week 3. All right, so this sample, which I'll call the gumdrops sample, that will be posted on the lecture page. Let me just put it where I can find it later. Okay. So there we are with everything other than it's time to start thinking about the first project. So last change of gears today, but we're going to get through early. So the project's coming up. And it looks scary because there's a lot of stuff going on. So I would argue that you can make it less scary by starting a REPL for it and beginning to build out some part of the project. Not everyone is comfortable with this, but you won't know if you're comfortable with this approach to problem solving unless you've tried it. The approach is to do incremental development. And what I mean by that is you develop your project to over a series of days or weeks in steps. And each step that you take, you are either adding something new or fixing something that you realized was broken, or you are improving something that you know you could now do better at, or you are doing some combination of all those things. So the idea is that you fire up your project and then you begin to inspect the project and its requirements and figure out what parts you can and what parts you can't do, and just see how far you can take it each time you revisit the project. Every time we do a new lab, you should have new tools at your command to solve the project. So in this project, we will use variables, inputs, which we're doing this week, formatted outputs, which we are doing this week and we did last week, and arithmetic. Okay, we haven't done arithmetic, so whatever involves arithmetic, I probably won't be able to do. That's okay. That doesn't mean I can't do anything. to implement a penny maker and a penny reducer. So what do we mean by a penny maker? A penny maker, and this is really just to force us to do arithmetic, but so it's going to seem like it's weird and artificial, it's because it is. But basically a penny maker will accept from the user quarters, dimes, nickels, and pennies, and then say, hey, all that stuff, if we were to convert that into a big old heavy bag of pennies, would be this many pennies. So you will do things like ask your user, how many quarters do you have there? And how many dimes do you have? And how many nickels do you have? And how many pennies do you have? And you will use that information to figure out, okay, if I turn all of that into pennies, what does that look like? We'll do arithmetic probably next week, I think. So if they tell you they have 3 quarters, you will take that information, you will multiply it by 25, and you will figure out, oh, that's 75 pennies. And I will then add that to, how many dimes did you have? You had 4 dimes, times 10 is 40 pennies. So I'll take the 75 pennies that I would give you for your quarters and add that to the 40 pennies I would give you from the dimes. And you'll keep doing that until you get to some total, like, here's a big bag of pennies. I'm keeping all your quarters and your nickels and your dimes. Okay. That's what the sort of first part of the project is going to do, which is something that you probably wouldn't typically do in the world, but who knows? And then the second part will be a penny reducer, which is to go in reverse. So the second part is someone comes to you with a bag of pennies and they say, reduce this down to the best combination of coins that you can give me, quarters, dimes, nickels, and pennies. So you'll have to do the math to figure out, oh, you had 1,000 pennies. Well, that's this many quarters, this many dimes, this many nickels, and then, sorry, but you're going to have a couple of pennies left over too. That's the second part. So there's a lot of math in there, and we will do math next week. Okay, so you can't do all of that work in Go, but maybe you can find some things that you can do. So our program will ask a user for 2 sets of inputs. We now know how to do that part. The penny maker is going to ask your user, how many quarters do you have? How many dimes do you have? How many nickels do you have? How many pennies do you have? So that is 4 of that same sequence. Prompt for quarters, variable for quarters, scan for quarters, prompt for dimes, variable for dimes, scan for dimes, prompt for nickels, variable for nickels, scan for nickels. You can do that entire sequence up to the point where you can say, well, now I have all the information. I don't know what to do with it. That's okay. You can print it out. You can say, you have given me this many quarters, this many dimes, this many nickels, this many pennies. That you can do, and then you will kind of trail off, waiting for the ability to do the math that will allow you to figure out how many pennies does that make. The penny reducer actually only needs 1 input, which is how many pennies do you have? And here's a chance where you might, instead of declaring a new variable, reuse a variable from earlier in the program, because you already have a variable that represents pennies. You're just going to use it in a slightly different way. So be it. Okay, so let's go set up a project and kind of just give ourselves some structure to begin filling out. So I'm going to make a REPL for this. It's going to be a Go. I will call it CSCI 20 Project 1. Okay, so now that I am this far, what can I do? Well, the first thing I can do is document it. All right, so I can do that part, and I've already gotten some points, I suspect, on the project. Let's go look. That's 25 points out of 500 just for having done that part, even if I do nothing else, which would upset the teacher, but I'd get my 25 points. It would upset me if anyone got sort of stuck as that being the last thing that they were able to do. Okay, I'm going to flush this thing out. What else does it say? All right, I will be careful about formatting and naming, and I'll make a couple of comments about that before we shut down. We're at 5:10, so we're good on time today. Formatting our program output, well, we've just practiced 2 weeks of it after this week's lab, so we're starting to get better and better at that. Pennymaker functionality, so that's 200 points. We already have some sense of parts of that, so we could probably get started on that. Penny reducer, we have some sense of how to get started on that, but let's just see what it might look like if I were to start today and sort of hit my dead end or decide that I don't want to work on it anymore today because I'd rather work on it more tomorrow. One thing that I would do is take advantage of a freebie here and just say, welcome to Boyd's Super Penny this is a moment where I'm allowed to be creative because there's no limitation on this part. So I'm just going to go ahead and be a little crazy with it and call it whatever I want. That's the name of mine, trademark Boyd. And then 2 line breaks. So go down to the next line and then go down another line. So there's a blank line after this. Great. So now as I'm starting to build out my project, one thing I will use is comments in my code. And the reason why I'm using comments is because I can put a note here, and if I stop working, I still have a note kind of reminding me where I left off. So part 1 is the penny maker. And then further down, I will have a part 2, which is the penny reducer. Even if I do nothing else today, I've kind of already got a little setup. I have a REPL for my project. I've put some notes in here about where I should be doing these activities. And I can even run it, and it will do something silly and dumb, but it will still do it. Welcome to my Super Penny extravaganza. I'm going to put a blank line above that. And I have started. Right now I have a couple minutes. I can go a little bit further, so why not do it? Before I do that, a comment about formatting. So Replit generally forces you to do good formatting. Every time you hit enter, it has already kind of moved you over a couple of spaces. So here's the general rule, and you'll see how we sort of build on this over time. This section here between the curly braces, we call a block. This is a block of code. And everything inside of a block starts tabbed over 1. Now in reality, that's just 2 spaces, but you should not have inside of a block anything that is butted up against a line. And in fact, in Replit, to achieve this, you'd have to purposely take that spacing out. So when you are inside a block, everything inside of it is tabbed over 1. Your eye will get used to what this is supposed to look like, but basically inside of this block, I want to be able to kind of quickly see what the block is, and that's easier if everything inside of it is tabbed over 1. As we get more and more complex code, this will even be more and more valuable and make more and more sense. But if I made a comment to you about the formatting of your source code, this is what I was talking about. I didn't dock any points for it yet, but I will begin docking points for it soon. So everything inside of a block starts tabbed over 1. Not tabbed over 2, not tabbed over none, tabbed over 1. So that everything kind of lines up. The comments line up here, the code lines up here, everything lines up here. The only things that might not line up are super long lines, but if you have a line of output that runs past the end of the screen and wraps around, break that up. Let me give you a quick example of that. So here's one that is bad style. In this program, I will do a bunch of different things with pennies and quarters and nickels and dimes. I got out of order. Oh, who cares? And then some other things. Just you wait and see. Okay, so this is bad style. I don't want things wrapping around like this. It just looks bad. So if you have this happening, this is what I would prefer that you do. You have two options. One option is you kind of use the edge of the screen as a guide and you break things apart at the edge of the screen. And by that I mean you put a new line character, you end the output, and then you start a new one the next line down. And then you get to the end of the next line, you break, you break the output, go to the next line, and you start a new one. So that is one way to handle that problem of the wrapping. It also means, by the way, that on the screen, it won't look bad. On the screen, it looks a lot more natural if you manually break it apart. So this is one way you can do it, is just use the edge of the screen as a guide, put new lines, and break it up. That's my preference. Probably, yeah, let's see if it'll work. So what happens if instead of that, we kind of do this? Yeah, it's going to look like junk. Let's just say let's do it that way. So use the edge of the screen as a guide. When you get down to the edge of the screen, manually cut it off and then start a new printing statement on the next line down with your new stuff. Now there will be times when you have something like I am going to do an elaborate output, %D, %S, %.2F, etc. And then you have a bunch of variables come up. In that case, you can and you should. You get to the edge of the screen, you hit enter and you break, and then you start listing out your variables here, and so on. That is okay to do for your list of variables. If you have sort of an output, well, the output itself doesn't go past the end of the screen, but the list of variables would make it run past the end of the screen. Then you can hit enter, put your comma, hit enter, and then list out your variables on the next line down. Replit will automatically kind of figure out this spacing for you. And notice what it did, by the way, is it lined it up with the quote. And it did that on purpose because that's considered good style. Okay, so just some thoughts. It is totally worth the trouble. It is very much worth the trouble to have quality output and to have quality code that makes your output that's easy to read and maintain. Okay, so Pennymaker. Well, I know how to do some of these parts. I can do a format.printf. How many quarters do you have? Do you have space? Good variable name, which is easier to read, and you're not going to type it so many times that typing out the word is a pain, and you will thank yourself later because it is so much easier to read code with good variable names as opposed to a bunch of letters where, oh, I don't remember what the R meant. Words are better. Then we'll scan for it. Scan F. That is an integer, so the verb is %D. I need to remember this mess for Windows. The new line is for everybody. The carriage return is a Windows weirdness. Remember the ampersand, scan the... So let's say, okay, I am ready to get up, which I am. So I'm going to leave some notes to myself here under part 1. about what to do next. So I need to get dimes. I need to get nickels. I need to get pennies. And then I need to do the math for the penny maker. And I could do sort of as little or as much of this as I want. Replit is out of sync. Man, I'm going to lose some stuff. Yeah, so that's a good question. Shadow Hunter asks, will that \r screw up anything anywhere else? And it will not. So this \r is safe to use everywhere, in any IDE, in any editor, in any environment. The only catch is if you don't use it and you are in a Windows system with your software, the inputs won't work right. So it's safe for everywhere, but required for Windows. So we just do it. That way it's guaranteed to work in Windows, and everywhere else just ignores it. So perfectly safe. Oh, darn you. So here I am. I have to redo all that because Replit got out of sync and bombed on me. So now I have to redo my notes for myself, which I'm irritated about. Okay, so, but this is how I can, so I just did an increment on my project. I played around a little bit, did an experiment, got rid of it, gave myself a little welcome message, you're in the program. I got to one of the required prompts, variables, scanning sequences. I'm going to shut down now, so I'm going to leave some notes to myself about what needs to happen next in this section. Leave a note to myself about the fact that I need to do math to complete this section, which is fine, either because I don't have time to do it now or I don't know how to do it. I have a note here telling me you need to do this. I might leave a note for myself, for example, like print out the quarters, dimes, nickels, pennies info as confirmation. So I might just put a note to myself like, hey, it'd be kind of cool here as my program is running down through its steps to print out a little message saying, hey, okay, I'm going to work on your 3 quarters and 2 dimes and 4 nickels and 7 pennies. Penny reducer, I might leave a couple notes to myself. So get pennies, maybe reuse pennies variable from part 1. Since that was noted for me in the project, and then do math for the penny reducer. I won't even put that. So there we go. I've now completed my first increment on my project. I should be in a running state. So one thing you might consider doing each time you sit down and do an increment on your project is before you get up, just try to have it in a state where it still runs even if it doesn't do the cool stuff just yet. I have 3 quarters. Done. I have an increment. Okay, so that's where I'll stop for today. That's most of the hour and a half that we try to stay inside of anyway. I got through my entire agenda for the day without going over, which feels darn good. I hope it included covering all the information that you need for the lab this week, some tips about how to get through the homework, and also hopefully if you are so inclined, you are encouraged to start the project knowing that this is a perfectly valid way to go about building your solution, which would be in steps. They didn't build Rome in a day, as they say. Okay, that's it. So have a great week. I will see you on Tuesday next week. Have office hours, as always, available through Zoom. Drop-in office hours open to everybody at 4 p.m. to 5 p.m. on Thursdays. Canvas inbox if you have questions. Piazza is a good place to drop general questions about your programming work. to swap ideas about how you're going about the project, things like that. Um, those kinds of posts to Piazza, you can just make a new post and stick them in there, and people will see them as new items that have come up in their feed. And then as a group, we can kind of all discuss what we're doing for the coding parts of our labs and project. Okay. Take care. That's it for me for today. See you next week.